In previous video, we have understood iodoform test for alcohol. We understood there how to apply iodoform test, what are the conditions for that, and what is the result for that. We have not done mechanism in that video. Now it's a time to understand mechanism part. The topic is involved in JEE Advanced and B.Sc level, not for 12th class. Now let's understand the mechanism of iodoform test. Before that, let me recall what kind of reaction it was, what kind of alcohols can perform that reaction. Ethanol and the 2-degree alcohols. This is 2-degree alcohol in which OH connected carbon have CH3 in its neighbor. CH3 in its neighbor. Ethanol also have a CH3 in its neighbor. So such alcohols can perform this test. Balanced equation was this. Iodine and sodium hydroxide mixture we require. On heating, this carbon, CH3 carbon will turn to CHI3. This carbon will oxidize up to carboxylic stage. So we will make a carboxylic acid of it. But this is acid and this is a basic condition. In that, acid-base reaction will happen. So finally, we will not have carboxylic acid. We will have a sodium salt of carboxylic acid. Plus 5 particles of sodium iodide will release out and 5 particles of water will release out. This was the reaction. Now let's understand its mechanism. Before start of the mechanism, let me tell you how to make this iodine and sodium hydroxide aqua solution. Iodine, as you know, in the solid form, it's a dark gray or bluish color solid. On dissolving it in sodium hydroxide aqua, we know that sodium hydroxide salt is dissolved in water. Mix it, colorless solution will be generated. Now in this sodium hydroxide aqua, we just need to add this iodine, due to which, and mix it, we will get colorless solution. This colorless solution will be used for iodoform test. Now, let's go for the mechanism part. The iodine particle which I have used, I2, the molecule of iodine is non-polar. It is non-polar. Non-polar because the electron shared between two iodine atoms are in center. Because there is no electronegativity difference, electrons are in center. So this iodine have a 0 charge, this iodine have a 0 charge, so it's a non-polar molecule. When it is dissolved in NaOH, aqua, as you know, in NaOH aqua, NaOH is dissociated in two parts. Sodium cation and hydroxide anion, OH negative. Now when these polar particles will come in the contact of non-polar, will do its polarization. Means, like when sodium is attracting or colliding with this particle, due to its positive charge, it will start attracting electrons toward one iodine. Like this. And iodine particle will break in two parts. This iodine atom which has lost its electron will turns to a positive iodonium ion, and this iodine which got extra electron will turns to iodide, which will be balanced by this positive particle. So in turn it will make NaI. What about this iodonium ion? We call it iodonium ion, iodine with a positive charge. Here we have negative particle. OH In OH, this oxygen is carrying 3 lone pairs with a negative charge because it have a 1 extra electron. With the lone pair, it will start attacking on this iodonium ion, due to which between iodine and oxygen bond will generate. Because iodine got 1 extra electron in its vacant orbital from this oxygen side, so its positive charge will finish, and oxygen has delivered 1 extra electron to iodine, that's why its negative charge will release. So this type of molecule will generate, which is known as hypoiodous acid. Now this is acid, and we know we are working in basic condition. This NaOH is already utilized, 1 basic particle is utilized. Here we will have an entry of another basic particle, another molecule of NaOH. You know what it will do? It's a acid is carrying H positive particle. It's a base which is carrying OH negative particle. H positive, OH negative will combine to produce H2O. First water molecule is generated here. So please keep on counting the water molecules, the NaOH which I am using, the iodine particles which I am going to use in this mechanism, and finally compare it with the actual reaction, the balanced equation which I have written. And because hydrogen and oxygen bond will break, electrons will transfer completely toward oxygen, so oxygen will become negative, which will be balanced by this Na positive. So here we will have another particle, NaOI, sodium hypoiodide. Sodium hypoiodide means after this first step, what we are getting, 1 iodine particle is going to react with 2 particles of NaOH, will give us 1 particle of NaI, 1 particle of NaOI, and 1 particle of H2O. Now let me tell you, these NaI and NaOI both are soluble in water. So they will not precipitate out, they will dissolve in water. So they will be again in the form of their anions and cations, like this. Iodide ion, sodium ion, and hypoiodide ion. They are moving continuously here and there in a water molecule. So this is the first step. This is happening with iodine molecule. Note it down. Now let's check what will happen next. From here, the role of hypoiodide particle will start. Let's take ethanol, on which we are going to perform this test. This is ethanol molecule. Now here we have a role of hypoiodide ion which was generated in initial steps. In hypoiodide ion, this oxygen is carrying negative charge, and we know oxygen is more electronegative than iodine, so the shared electrons are more toward oxygen side. That's why this iodine is carrying partial positive charge. In alcohol, this oxygen is carrying partial negative charge, so this alcoholic oxygen will start attacking on this iodine of hypoiodide ion, due to which, first of all, the oxygen hydrogen bond will break, because we know oxygen is stable with 2 bonds. And how bond will break? It will get these electrons because it is more electronegative than hydrogen, and from here hydrogen will release out as H positive, and these electrons it will use to make bond with iodine, and obviously between oxygen and iodine bond will break, electrons will completely shift toward oxygen. These electrons which are coming from iodine side, this pair, this oxygen will use to make bond with this hydrogen. If I will draw it like this, you will understand. This pair, this oxygen is using to make bond with H positive. So what will generate? this will generate. The positive charge of hydrogen will finish because it got extra electron of iodine, and this oxygen is as it is because it got extra electron from iodine, due to which it will become -2, but at the same time it has delivered that electron to hydrogen, so it is OH negative as it is. Oxygen have a -1 charge. And here we will have the generation of this molecule. Now this is an intermediate which is generated over here. Now you can check, iodine is electronegative atom, halogenated. Oxygen is electronegative atom. So what this group is doing, it is pulling electrons toward itself, due to which this carbon will start pulling electrons from its hydrogen. That's why these hydrogens will become highly positive, or you can say acidic. Due to high positive charge, the OH negative which was generated here will start attacking on them. Like this. Due to which these electrons will completely transfer toward carbon, and because this group is attracting electrons, so this carbon will shift these electrons toward oxygen for bond formation. And we know oxygen is stable with 2 bonds, so what it will do, this bond will release out, will break like this, and these electrons will go toward iodine because carbon is providing these electrons here. So due to repulsion, that iodine will release out. From here H2O will generate. Please keep on counting water molecules. H2O is generated, and from here I negative will generate. This one. And what about this particle? This particle will turns to this. What is this? Aldehyde. Aldehyde means ethanol, alcohol, firstly oxidized during this process. And this hypoiodite, this one, is working as an oxidizing agent here, because due to this everything is happening. Now the I negative which is generated, it will be balanced by Na positive. Which Na positive? In first step NaOI negative was generated. Of that OI we have utilized, Na positive was left. Please check the video. Na positive was left. That Na positive will stabilize this I negative, and second NaI will generate. First NaI already I have shown you in the start of the mechanism. This is second NaI, sodium iodide. Please keep on counting. Aldehyde is generated. Alcohol oxidation has happened. Now let's check what will happen with this aldehyde. Now mechanism is very easy. The complicated part we have solved. Now it's a very easy mechanism. Now this group, carbonyl group. In this group, as you know, oxygen is highly electronegative. So it is attracting these electrons toward itself, so negative charge is there. Carbon is strongly positive. Due to strong positive charge, it is attracting electrons from this carbon side. In turn, carbon is attracting electrons from its hydrogen, due to which these hydrogens are becoming highly acidic. This is the main point. Now that these 3 hydrogens are highly acidic, And we know we are using basic condition. NaOH particles we are using as a base. So what these Na positive particles will provide? Na positive, OH negative. These hydrogens are acidic. This is base. So what will happen? First hydrogen atom is attacked by first NaOH, due to which release out of, here I am releasing H2O. Keep on counting water molecules, NaI, NaOH, which I have used. When bond will break, obviously carbon will shift these electrons to that side, because this group is electron attracting group due to oxygen. And when this bond will generate here, this carbon can make maximum 4 bonds. If this bond is going to be generated here, pi bond will break and electrons will shift toward oxygen, due to which this compound will turns to this molecule. Double bond here. This oxygen will get now 3 pairs with a negative charge, H. Enolate ion. Enolate ion. This enolate ion will make, let's rub this name, please note down, it's a enolate ion. This enolate ion will make iodine particles polar. Why? Because of their pi electrons. As iodine particles will come in the contact of this enolate ion, as you know, pi electrons are perpendicular to the molecule. So what they will do, suppose this iodine is coming in the contact of this carbon. Pi electrons will come toward this iodine, because this is unstable. This is not a final compound. It will change itself. It will do polarization of iodine molecule. How? Like this. These pi electrons will repel these electrons, due to which bond between this iodine atoms will break, and here this pi electron will make bond with this iodine. Because these pi electrons are going toward this iodine, on this carbon vacant orbital will be generated, which will be filled by oxygen back, like this. What will generate? H, C, H. Between carbon and iodine bond will generate. Because this iodine has lost its one electron, so it should be a positive charge on it. But wait, one electron is coming at the same time, so it will be neutral. This carbon will get vacant orbital, positive charge, which will be filled by oxygen, so it will also become neutral. Everything is neutral here. This way. What will release out? I negative. Now this I negative will be balanced by this Na positive. So third sodium iodide particle will generate. This one. The reaction is not stopped yet. Similarly, the mechanism which I have written in front of you right now, the attack of H positive with one basic particle and then one iodine particle, similarly, 2 times this will happen, because these 2 acidic hydrogens are left over there. Means, again you have to repeat this circle 2 times. So please tell how many NaOH will be used over here. Here we will use 2 more NaOH particle for 2 times hydrogen, 2 hydrogens. I am not writing again the same. Directly I am telling the same step you have to repeat 2 more times, because 2 more acidic hydrogens are left. 2 NaOH will be utilized. 2 more iodine particles will be utilized. 2 more H2O will be released out. And 2 more NaI particles will generate. And after this, let me rub this one. Please note down everything. Here I am writing. After release of these two hydrogens, the particle will become this. I hope you have note everything. So I'm rubbing it. Now mechanism will be further proceed with this particle, this one. Now what will happen with this particle? Let's check. In a basic medium, please count another NaOH. Which NaOH it is? Count it. Na positive, OH negative. Now this OH negative will attack on which particle? Hydrogens are not there. H positive particles are not there. This is a carbonyl group, and in carbonyl group, oxygen is carrying high negative charge, carbon is carrying positive charge. Now this carbon will be the next target of this OH. Attack. Pi electrons will shift toward oxygen because carbon can make maximum 4 bonds. This bond will break, and obviously oxygen is more electronegative, so these pi electrons will shift toward oxygen, due to which this will generate, which will be balanced by this negative oxygen will be balanced by Na positive, like this. Carbon with 2 oxygen atom, unstable condition, crowding problem. Many a time I have told you, if a carbon containing 2 oxygen, so it is a highly unstable condition. How it will release out the problem? This oxygen will, first of all, from here, understand, this bond will break. Between this carbon and this carbon, bond will break, and electrons will shift toward this carbon. Reason? Because this carbon is connected with highly electronegative atom. So these are attracting electron. They are attracting electron. As they will attract electron, bond will break. This carbon will have a vacant orbital, positive charge, which will be stabilized by this oxygen at the same time. So everything will be perfect in this fashion. Now on this carbon, extra lone pair will generate with a negative charge, and this carbon will make double bond with oxygen. H as it is, OH as it is. Na positive will separate out from oxygen because now this oxygen is stable. What is generated? Carboxylic acid. Now, this carbon can be stabilized by sodium also, but wait. In chemistry, sp3 hybridized carbon with a negative charge will never get stability from Na positive because between them the bonding is not so strong. Neither it is complete ionic nor it is completely covalent. So bonding is strong, bonding is very, very weak. Means this sodium will never stabilize this carbanion. How it can be stabilized? Only one way is there. It is acidic. It will release out H positive. Oxygen will shift electrons toward itself, due to which oxygen will become negative. That negative oxygen will be stabilized by Na positive, and this H positive will stabilize this carbon. Carbon hydrogen bond, we know they are very strong and stable bonds. Vacant orbital is there on hydrogen, it will stabilize this carbonide. So finally, what we are getting, this we are getting CHI3, what it is? Iodoform, yellow color precipitate which will settle down. And here what we are getting, at the place of hydrogen, who will come? Sodium will come. This one. So what it is? Sodium salt of carboxylic acid, and obviously methanoic acid, because which alcohol we have used in the start? Ethanol. And in previous video I already told to you the trick. This carbon will turns to CHI3. Check whole mechanism. and this carbon will oxidize itself to carboxylic stage, which we have done, which will react with base to create sodium salt of carboxylic acid, which will happen like this. CHI3 is generated. Now, when you will count everything, so you will find that in this whole mechanism, total 4 iodine particles, 6 NaOH particles are used with 1 particle of alcohol, with the release of CHI3 is there, 1 sodium salt of carboxylic acid will be there, 1 particle of that, plus 5 sodium iodide are released out and 5 water molecules are released out. Please count and check. That's it. This is the end of the video. This was the mechanism of iodoform test. Thank you very much.